Okay, good morning, everybody. My name is Greg Kurtz. I'm the Technical Director at the International Ground Source Heat Pump Association. And thank you so much for joining us for the July Dig Deeper webinar. And we have people gathering in, so we'll just get started as they come in. Before we begin today's webinar with our guest speaker, I have a few announcements to make. And first one is regarding our town halls and dig deeper webinars. So if you'd like to speak at one of these webinars, we are accepting abstracts, and we will also have advertising available. These are recorded, and any sponsorship advertising stays on the recordings and will be promoted for future viewers that may want to watch the recorded presentation later. Please go to IGSHPA.org, and there you can contact us if you'd like to advertise or submit an abstract for our town hall or Dig Deeper webinars. So the next thing I want to bring to your attention is save the dates. Our 2027 annual conference is already being planned. So as you can see on the slide, we have that set up again this year in St. Charles, Missouri, again at the Ameristar Casino. And we want everybody to save this date and share it with your colleagues and like-minded organizations. All of the most important information will be available online, like registration, hotel details, sponsorship opportunities, exhibitor information, and presenter tracks, which will be posted as we get closer to the date. So I want to encourage everybody to please visit the IGSHPA website to secure your reservations today, and especially if you're interested in exhibiting or submitting sponsorships. This conference is one of our biggest opportunities each year to connect the geothermal community, industry members, and partners together. And so we invite attendees to reach out if you have any questions regarding participation or logistics using our info@igshpa.org. The next thing I want to bring to your attention is we are still looking for input for our IGSHPA databases. Some of the advantages of being an IGSHPA member is to help us build an industry database to assist the industry and the public. So please consider adding your projects and any details you may have to help us out to this database. We may get inquiries which are looking for those type of resources. So we do get quite a few monthly people looking for a similar project they're thinking about doing. And so it helps if they can see those kind of databases and go look at a project that someone's done similar to what they're thinking about. So if you have those, please let us know. We'd love to add them to our database. Next, our Geo Outlook magazine is back, and it's online now, and plus the back issues. So it's located under the webpage under the media link. And this is something that everyone is interested in to read, even the past magazine editions. So we're accepting articles and ads for the coming next edition now. So please reach out again to info@igshpa.org. We are today providing CEUs for those of you attending the live session today. If you would use the chat or the Q&A message to request those CEUs for today's webinar, that will be helpful. And if you're watching this recording of this webinar, you will need to have the webinar code. And when you email IGSHPA to request the CEUs for watching the recorded version. So if you watch the slide here, we've got the webinar code today. You want to use that when you email info@igshpa requesting the CEUs for watching the recording version of today's webinar. And just a couple more housekeeping items. So if you have questions and so forth, sometimes we'd had some trouble with the team software platform, so forth, talking back and forth in the chat questions and the Q&A. So, this will kind of help, this slide will kind of help understand that. We'll be watching the Q&As as we go, trying to pull out those questions at the end of today's presentation. This way John has plenty of time to get through his whole material, and we'll try to answer those questions at the end of our session today. And if we don't get to them all, we'll reply after today's session by email and try to follow up on those questions that you may have that we couldn't get to. So we'll have that. And this is the housekeeping slide again, just regarding the Q&A. If there were some issues, this slide kind of points out how to get around that, but I don't think anybody's having that issue now. And lastly, we have our disclaimer and potential conflict of interest message we must read to everybody before we introduce our guest speaker today. So it's my pleasure to introduce John Manning as our speaker. But before he does, this upcoming presentation represents the opinion of the presenter and does not represent any official position or opinion or endorsement of products or services by IGSHPA or its members. The IGSHPA town halls and Dig Deeper webinars are member updates and education on the latest information, the geothermal heat pump industry, and we're not meant to endorse one technology or brand over another. It's the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. So again, it's my pleasure to introduce our speaker, John Manning, today from Auburn, New York. So John, feel free to share your screen anytime you're ready, and you may get started.
Okay, thank you, Greg. Do you see my screen?
I do. Looks good.
Awesome. Well, thank you very much. And I want to start off a little bit by saying I really appreciate the opportunity to share the work that our team at Phoenix Energy Supply has put into this over the last many months and potentially years. This software was developed for an internal need because our plethora of spreadsheets was becoming a problem. So we embarked on developing a software that would help us in our design efforts. And then my son challenged me and said, why don't you make it available for everybody? So that's what we're doing. And let me start off by reiterating what we have learned over our experience with the geothermal industry, and that is a successful geothermal project requires three significant areas of engineering know-how, and that includes energy modeling or load calculations. What are the loads that are going to accumulate and impose BTUs to be extracted from the ground or rejected to the ground? There's also loop sizing, which in itself is full of parameters that have to be evaluated and calculated. And then the third leg, the hydraulic design. And that's what our software is focused on. We're not sizing loops. We're not doing load calculations. It is that hydraulic design function that we have focused on. And if any of the three legs don't support the end goal of creating a successful geothermal project, two of the legs may be perfectly fine, but if any one of them collapses, there may be lawsuits in the future. And unfortunately, I've seen way too many jobs that do not perform as well as they should. And quite often, it's the hydraulic design aspect, because there simply is not an easy to use tool that's developed for geothermal to really make that process quick and accurate. Loop field sizing, just to reiterate what I think we all know, is a function of energy, not demand. Energy flows in both directions, which is kind of unique for most heat exchangers. Thermal capacitance, that's another aspect of geothermal that's different than, say, a cooling tower. I pose a thought experiment. Does a 200-ton data center have the same energy profile as a 200-ton office building? And if you've been in this industry at all, you know they're totally different. So the foundation of any geothermal system is understanding that energy model over time, and it has to be realistic. So those tools are out there, and here is a simple matrix of a lot of the tools that I'm sure many of you are familiar with. We use the Carrier HAP in our shop, but these are all available to analyze energy flows. So that's out there for you to work with. Let's talk about loop field sizing. Certainly local geologic characteristics such as formation temperature, thermal conductivity, thermal diffusivity, moisture, loop configuration, and certainly grout thermal characteristics. And there's tools out there that can evaluate and help design loop sizing. And lately, we've been a big user of LoopLink Pro, but they're all got their pros and cons and are available for you to help in your design process. But there's a weak link. And although we calculate loads to the nearest BTU per hour, and we calculate loop lengths to the nearest foot, I do get a kick out of engineering drawings that go out and ask for a loop depth of something like 383 feet. I think we ought to round off to the nearest 50 foot, frankly. But we express both of these calculations with a high degree of confidence. And that reflects a degree of accuracy. However, when we calculate pressure drop and select pumps, we generally wet our finger and hold it up in the air because it's a tedious process. I have very complex spreadsheets where I tried to do it with the tools that were available to us. And frankly, let me illustrate how difficult it is sometimes to model hydraulic performance. Here are several different types of pipe materials. From the left, we've got PVC and steel with Schedule 40 and Schedule 80, both of which I don't think should be used on geothermal, but they are being used. So we've included those in our software. The backbone of our industry is high density polyethylene in a variety of diameter ratios. Polypropylene has certainly shown up on quite a few jobs. Certainly copper, hose, and PEX tubing. All these materials are available in 1 1/4 inch, but 1 1/4 inch doesn't always equal 1 1/4 inch. So for these different pipe materials, the inside diameter is different. And is it inside diameter that's important? No, it's really area. So when we square that radius, the deviation in area starts to really stand out. And that area translates to a fluid velocity. So at 12 gallons a minute, each one of these pipes materials, even though they're all 1 1/4 inch, are operating at significantly different velocities. Now, it's not velocity that's important, it's the square of velocity that dictates pressure drop. So even though all these pipe materials are 1 1/4 inch, the pressure drop per 100 feet of pipe ranges from 3.2 feet of head to 11.8 feet ahead. And I think it's incumbent upon us to define our jobs very specifically, because although we may specify high density polyethylene DR11, it shows up on a job. The contractor loves to run PEX tubing because he can do home run circuits and not spend the time fusing joints together. So it is this kind of variation that needs to be accounted for in our designs. And this gave rise to what we call GeoDesignPro. And like I said, we developed it for our own internal use, but we're willing to share it. It's available at no cost, and it's a web-based program. Our mission was quite simple. We wanted it accurate and to accommodate all the different variations you might have in a system. It has to be comprehensive. It has to do a lot of functions that engineers have to do to get their design documents together and instruct the contractors how to install it. It has to be fast. If we can't do it quickly, I'm sure I can't get you interested in using it. The ultimate goal, though, is success. Our whole industry is dependent upon successful projects. And we all know one bad job travels a lot faster than 50 good jobs. So we have got to be more diligent about avoiding problem jobs. In the area of accuracy, for those of you who may remember your fluid dynamics courses, this equation you may recognize, and it includes things like fluid density, the velocity squared, a friction factor that incorporates things like Reynolds number and internal roughness factor of the type of pipe you're using. And you'll recognize this as the Darcy-Weisbach equation, considered to be the gold standard in trying to calculate pressure drops. Also, in the area of accuracy, our program includes 13 unique dimensional materials in the way of piping, 16 different sizes from 3/4 inch up to 24 inch. They each have their unique inside diameter and roughness factor, and these are essential for both pressure drop and internal volume calculations. We take into account the fittings, whether it's an elbow or a T. We use the equivalent length method to calculate the impact on pressure drop, but we don't include those equivalent lengths when we calculate volume, further improving the accuracy of these calculations. Antifreeze. We spent a lot of time developing the equations necessary that calculate the fluid properties at the lowest operating temperature that's being specified in your design, the type of antifreeze, and the freeze point that you're specifying. And from that, we translate that into how much antifreeze is actually required, expressed in volume, not weight, which is often used when analyzing antifreeze. Automatic pipe sizing. The program will suggest pipe sizing for diameter, and it's based on the simple velocity. We like to see that above 1.5 feet per second, and that's a starting point for you to select and possibly override those selections. The program is comprehensive. We have so many little tasks that are being performed in the program. And what I'm sharing with you today is really just the tip of the iceberg. All these capabilities are built into the software. And I'm going to share some of them with you today, but I really encourage you to sign up for the program, kick the tires, and discover the various Easter eggs that are embedded into the software, which you might find very useful. So if you go to our homepage at geodesignpro.com, this is where you can sign up or sign in. You go on the sign in page, and as soon as you sign in, it takes you to our first tab, the project tab. Pretty much self-explanatory. You can document your project name or location, your client's name, and so forth. But you can also specify your min-max entering water temperatures, a flow rate that you wanted to design to. And I encourage you to review the work that Steve Cavanaugh has done over the years that he's helped this industry. And although heat pumps are rated at 3 GPM per ton, I think you can benefit your overall design by considering as low as 2.25 to 2.5 GPM per ton, which is fundamental to a lot of the work that Steve has done. You can also incorporate diversity factors to help in gauging the pump and the pressure drops of your system. Antifreeze, we offer propylene, methanol, and ethanol choices. You can specify the exact freeze point you're looking for, and the program will calculate the required concentration. You can select a default manufacturer and series. Right now, we have over 40 different heat pumps series loaded into our software. And you specify the default here, but zone by zone, you can override it and pick a different manufacturer or a different series of heat pump. Now, Phoenix Energy Supply is proud to offer all these different options for heat pumps. And these logos are linked directly to the manufacturer's website. So if there's something else you need to discover about them, it facilitates that. Also, we're more than willing to put heat pumps into our database that we don't offer. And certainly Water Furnace, one of the leading brands in the market. And if there's any manufacturers on the call, send us the data of products you'd like incorporated, and we'd be glad to do that. The thing I really want to point out is a unique feature called Book Tech Support. And when you are working on the software or just want another set of eyes on your design, you can book a 30-minute or longer. We had an engineer the other day sign up for 30 minutes, and an hour and a half later, we concluded the call. So we're very eager to hear from you and help you through the software and also give you feedback on design details of your system. So the next tab are zones, and you can identify each zone that is being served by a particular heat pump. The process is quite fast. Oh, maybe not that fast, but step by step you add your zones. You can override the default tag nomenclature. You can override the zone name, customize it any way you want. You input heating and cooling loads in kBtus per hour. The default manufacturer pops up, but you can override that. The software will actually pick the right size heat pump based on your loads, but that too can be overridden if you feel it was off slightly. It will populate the flow rate at your GPM per ton that you specified. You can specify the pipe material, the diameter. In this particular case, I overrode the automatic suggested size, and I put 1.25 inches on every one. You define the length of that, how many elbows are in that circuit, any CV values of two-way valves or strainers, and so forth. But what I want to focus on is the color-coded alert to where is that pressure drop in that circuit. The first color, being red or green, is the heat pump. And you don't have any control over that. That was decided by a design engineer at the various manufacturers. But the part of the system you can control are the pipe diameters, the pipe material, the type of two-way valves, and so forth. So if the heat pump is green, that indicates that it's at least 70% of that total pressure drop, and you've done a good job reducing pressure drop on the parts you can control. If the heat pump shows up as red, then it's sort of suggesting to you that maybe your options for pipe diameter or zone valve need to be re-examined. And in this particular case, I'm going to take a close look at our pipe diameters. So off on the left, you'll see I've changed a couple of them, or actually 3 of them, and it changed the color coding. And the 4th one down with the red heat pump is at 20.5. Yes, I could perhaps take that pipe diameter up to 2 inch, But because it's so close in pressure drop to the number 5 heat pump, I kept it at 1.5 inches because they're closely balanced. The program will also indicate if you need a balance valve. The MV indicates a motorized valve that for variable speed heat pumps pretty much acts as a balance valve because the heat pump will control it directly. And you can dial that into min and max flow rate on your system. But if you don't want to take the time to define all your zones at this point in your process, there's an option to just analyze the loop field. So you check that box and a new window pops up where you get to specify a flow rate that you're designing to. And you put a placeholder in for your internal part of your system pressure drop. In this case, we said 25 feet of head. You put a percent of volume that might be in the interior piping. And the other thing that I want to point out, as you tab through the various input fields, you'll get these tooltips that automatically pop up and give you a little guidance as to what the software is looking for. So from there, you go right to the loop field tab. And in this particular case, I've got one group of 8 bores. Each bore is using 1.5 inch polyethylene DR11, 500 foot deep, with a reverse return manifold. The tap spacing is roughly 20 feet spacing between the bores. The runout pipe is 100 feet to get to the middle of the reverse return manifold. Then the program automatically suggests 4-inch pipe. However, if you're happy with the design details here, and each segment of the reverse return manifold is being automatically calculated to determine the proper diameter. And you can override any of these. You can change the length between bores. Sometimes they may only be a foot apart because the bores are on opposite side of the reverse return manifold. So these details can all be modified, but once you're happy with these details, one click of a button and it'll instantly produce a detailed drawing of that reverse return manifold, not only calling out the diameters and the pipe DR and length between each bore, but it calls out the fittings that will allow a contractor to fabricate this in the field. Now, there are certainly other choices. You can use saddle fusion, but this provides a starting point in which 2-inch and smaller is socket fused and 3-inch and larger is all butt fusion technology. So if you're happy with this drawing, you click on download a DXF file, and then you can put that directly into your own drawings. And one option you have is a manual mode where you override the auto selection feature. And in this case, we've changed that 4-inch pipe and thought, okay, we're going to save a little money. We're going to go with 3-inch pipe. However, our green indicator for the loop field pressure drop being less than 70% of the total gives you a visual cue that maybe you could do better in terms of pressure drop. And in this case, that small change of changing a few lengths of pipe from 4-inch to 3-inch increased the pressure drop of our loop field by 28.4%, which immediately shows up on the far right of our desktop. There's additional information that is also updated live as you go through your design. And we'll blow that up So you can see it. You have your design flow rate, the total bore footage that's installed on your loop field. And then there's a parameter that I've used over the years as a guide of how many GPM per 100 foot of bore. And it turns out that if you're at 2 GPM, plus or minus a half, from 1.5 to 2.5 GPM per 100 foot is an indicator of whether or not that loop field is sized properly. If you go below 1.5, and especially significantly below 1.5, I would suggest your loop field is over-designed. If you go way above 2.5, up to 3 GPM, I might question that loop field is undersized. So these are just key parameters to help guide a design. But I want to take a minute and talk about balance. It's sort of a pet peeve of mine that I feel strongly about balance valves on loop field manifolds. And if there's any doubt about how I feel about those things, hopefully this removes any doubt. I've been to too many jobs where balance valves were installed on the manifold, and they're all in a wide open position. Nobody uses them to balance loop field flow. So what I want to illustrate to you is how our software can help you achieve the type of balance you want and actually improve performance. So this loop field, I have 5 groups. Each group is 3 vertical bores with 1.25 inch pipe, 350 feet deep. And I'm going to flip my program into a manual mode so I can do some other work with it. And one of the items that shows up in this summary is the difference between design flow and actual flow. So the software looks at all the hydraulics associated with these parallel circuits, and they're not balanced because of the different lengths of runout pipe that is going and reaching each one of these groups. So that is the imbalance that we try to address with balance valves. But let me illustrate how the program can help you balance. And this area, we call it section B length. This is where you can put in a length of different diameter pipe in your runout pipe. So let me sort of summarize this in a table. So we've got our 3 groups, or our 5 groups with 3 bores in each group. They're technically all identical, so the design flow rate for each of those groups is 16 GPM. Well, the program tells you the actual GPM, and then I calculated what's the percent of deviation from design. So this is a fairly worst case scenario where our runout pipe is 40 feet longer for each group. You'll typically only see 20 feet difference, but I wanted to exaggerate this to some degree to really illustrate that plus or minus 10% imbalance. Well, if you feel compelled to really balance those perfectly, the way we do that is put in a length of different diameter pipe on a runout circuit. And the closest group, yeah, you put a little more of 1.5 inch pipe instead of 2-inch pipe, and so forth through all these groups. So that simple task has achieved 100% balance. And I would suggest it's probably more accurate than balance valves that are typically only accurate to plus or minus 5% anyway. So this is one approach, and by doing this, we've actually saved money. We're using smaller pipe. The internal volume gets smaller, so we saved a little bit on antifreeze. So for virtually no cost, we've achieved perfect balance. But I would say, let's look at it a different way. Let's take that furthest circuit and we're going to convert it to 3-inch as the runout diameter. And then we're going to balance it by using different lengths of 2-inch on each of those runout pipes. And we've still achieved 100% balance. Yes, we spent a little more money on pipe, but at the end of the day, we've achieved a 28.9% decrease in pressure drop. We've achieved perfect balanced flow without adding the permanent pressure drop of a wide open balance valve that simply translates to more pumping energy than what the system should have. Let's move on to the distribution tab. This is where you get to model all the interior piping of a system. And here we've got our 5 heat pumps that show up in an unassigned box, but by simply dragging and dropping those into a circuit box, we have now created a distribution system. And you can identify what room the heat pump's located in. You can change the order in which these are being fed simply by a drag and drop function with your mouse. You stipulate what kind of pipe material, how many elbows. The program tells you the flow rate, just for reference sake. You can specify the different length of the pipe upstream of the node or the T, that is the branch that's feeding a particular heat pump. The program calculates the proper diameter, which you can override if you want. So this functionality is all built in, and you can model the entire distribution system a variety of ways that I can't go into all of them today. We have also built in the capability of capturing what I call the mechanical room or the common piping in the system. You stipulate the piping material in your mechanical room, the diameter, the length, the number of elbows. You can specify a bypass flow rate if you want to have some sort of bypass filtration system, which forces the pump to pump more fluid, but we don't allow it to influence the pressure drops in the system, because that fluid is simply going to flow from the discharge side of the pump back into the suction side of the pump. You can enter CVs of all the various equipment you might find in a mechanical room, whether it's a strainer or an air separator or a triple duty valve. You can incorporate all that into your calculations. I want to talk for a minute about expansion tank sizing. I've seen way too many jobs with enormous expansion tanks on geothermal systems. So what you get to specify is a minimum operating pressure that you want to see in your system, typically to keep the net positive suction head of a pump satisfied. So in this case, we're stipulating 15 psi. The program will automatically tell you what to expect in the winter time, because as temperatures drop, counterintuitively, pressure in the system goes up. And this is the nature of polyethylene pipe. And the program takes into account all the dynamics, the different modulus of elasticity for polyethylene over time. The program will also suggest a charging pressure. So if you're initially filling your system with neutral water temperatures and ground temperatures, might be 50 to 60 degrees, it will say, charge it to about 20 psi. And under these conditions, you don't need an expansion tank, which most engineers almost always want to put an expansion tank in. But if you're willing to let the pressure fluctuate from 15 to 27 psi, you don't need an expansion tank. Now, if you really want to tighten up the range of pressure. Let's say you only want 1 psi of fluctuation. Well, then the program will tell you you need an expansion tank that can accommodate 24.6 gallons of fluid. So you can size one that can handle that. And if you really want to dig deep into the engineering calculations behind all this, I would suggest looking at a video we created. It's on our Phoenix Energy Supply YouTube channel. So I'd encourage you to look at that. From a flow center selection, we have a variety of readily available flow centers. These are typically maybe for 120-ton systems or less. And that the program will identify in the lower table those that meet the requirements, and it'll indicate whether it provides partial redundancy or full redundancy. But if you don't want to use any of these flow centers, there's an option down here on the lower right that if you click on that, it brings up a window that you can describe the pumping system you do want to incorporate into your system. And you can enter a budget cost to help keep track of the estimating function of our software. Moving on to the schedule tab, this is where all the heat pumps are laid out in a schedule type structure. And one of the key elements is a configure button. You click on that, and now you get to define the heat pump in virtually every detail that the manufacturer offers. So you go through and define whether you want copper or cupronickel heat exchangers, whether you want a hot water generator or a desuperheater, whether it's a vertical or horizontal heat pump, and so forth. You go through that process, it completes the model number, so there's no ambiguity about what you're specifying. It also brings up a list price of that particular configuration. You can move on and click on accessories, and I'll discuss one of the accessories. Let's say you want the IntelliZone 2, which is available on Water Furnace and Geostar products. And I just saw the Climate Master new zoning package, and that in itself is a pretty exciting product. But if you want zoning, it also gives you the ability to configure that zoning. And by that, I mean you get to stipulate how many extra zones above and beyond one. So how many extra zone stats do you want? Oh, three. So a total of 4 zones. You can also add dampers. You can specify the size of the damper, whether you want a 3-wire or 2-wire damper, the quantity, and the program will give you the part number, the list price, and an idea of the CFM that's appropriate for that damper. So you go through this process. You save the configuration. You do that for all 5 heat pumps, and the program will automatically populate the various electrical fields associated with that particular heat pump. So if you specified a IntelliStart, it'll look up the locked rotor amps that you're benefiting by installing a IntelliStart. You can export this schedule to an Excel spreadsheet where you can modify it to your heart's content. The Bill of Materials tab, it keeps track of all the decisions you've made throughout the process and loads them into the bill of materials, where you can override the pricing if you feel your pricing's different. And if you do that, it'll retain those prices as part of this project. So you don't have to rely on our embedded numbers. You can use this to come up with an estimating tool to help keep track of the impact of your decisions. Going forward, we're going to allow users to request a quote, or actually order materials. We move on to the report tab, where we can click on a little button called Generate AI Narrative. And when you click on that, it'll review all the various parameters that you've selected, and it'll generate a brief narrative, both as an executive summary and every section throughout the report. You can export this as a PDF or export Excel, which will simply export the tables that are being generated in this report. Feedback. We have a contact tab, and we're not going to be able to improve this software or meet your needs to the level you want unless you give us feedback. And so it's critically important. I've been in this industry long enough to know that only through our collaboration will we get better. So I encourage you to give us feedback. And I also want to reiterate the option for you to book a one-on-one session to discuss details of the software or your design. So with that, I think I've done it with enough time for questions. So if there's any questions in the chat, I'd be glad to take a stab at answering them.
Okay, sounds good, John. Thank you so much. Wow, pretty good. Um, Very exciting. Glad to see that come out. I'm looking for questions. I see one in here. Looks like Sherry's asking, why does the program not include geological parameters for loop size calculations?
Well, that was certainly a rabbit hole that I thought about doing up front, but I really felt we need to focus on the hydraulics and not loop field sizing. There's software out there that already does that. So we were trying to fill a need within our own shop originally and to get rid of the dozens of spreadsheets that we had developed over the years. So our software is really focused on hydraulics, pressure drops, pump selection, and a lot of other tasks that need to be done.
Okay, so that makes sense. So it's not a all encompassing in regards. You may have to use another software program to help you with that final analysis, but the details you've got I see in this pressure drop program is really pretty awesome. So that's great. I see another question from Andy. He's asking, does the software have the ability to change to metric pipe sizes? For example, SDR, OD sizing. Are we able to add custom pipes? There is a 45 millimeter SDR11 OD loop in Europe that we would need to incorporate any calculations we perform.
That's the exact type of feedback that I'd love to get from users. Tell us what you need and we will do it. Currently, it does not do metric, but we can certainly incorporate that.
Yeah, yeah, very good. That's a good question. And while we're on that topic of metric pipe sizes, just for the audience's benefit, and I want this recorded too, is that in the U.S., the North American market, there really is not easy availability of metric size pipe and fittings. That is more of a European thing. So you don't want to go to Europe and buy that pipe and bring it here and then look for fittings because you're not going to find them. We tend to not do that mix up between the continents. So for everybody's benefit on metric versus standard pipe sizes, in the North American market, we don't see that here unless somebody's brought some pipe over from Europe. But then you need to bring the fittings and everything required for that type of design. So that would apply more to those market specific. But
Well, Greg, I need to remind you, we are the International Ground Source Heat Pump
this is
Association.
true. We are, but it depends on where the users are and what the products are that they'll find in their markets. I want to make sure everybody understands that. But for sure, we are international. We appreciate our international members and audiences that are following along with us and supporting us as well. We do everything we can, and sounds like John could do some customization for you on that. So that would be an easy thing, maybe. All right. I see another question from Rick. He's asking about flushing speeds. John, does the program give you anything on that?
Yes, and under the loop field, once you get all the parameters set in your loop field, scroll down to the bottom of that tab, and it'll tell you exactly the flow rate and expected pressure drop of what the flushing requirements are to achieve that 2 feet per second that we all like to see. I always like to push it above that 2 feet per second, but it does give you that minimum purging flow requirement based on all the geometry you've put into the loop field piping.
Okay. All right. Um, I'm looking through, see if I see any more questions. I see several comments, all positive, but anybody else got any questions? Give you a minute to throw them into the chat or the Q&A here. If you're having trouble with that, maybe turn your screen on or wave or say something, turn your mic on, and we'll let you ask the question if you're not able to type it. But yeah, it looks like you've got a lot of good design features into it so far, and that certainly should make people's jobs easier. And I like the idea of being able to have the drawings exportable and your documents that you can output from that. That's pretty cool. And maybe you'll get more manufacturers to give you the inputs for their load, for their pressure drops on their equipment. And you can even expand the database, but you've got a good start on it. So that's looking good, John.
Well, it's certainly been I'll say a labor of love for the past year or so. And I'll admit, what it takes now to develop software is amazing in terms of tools and the impact of AI. I've personally written 70,000 lines of code and I don't know how to code. Let's put it that way.
Well, it's good to have the tools to do that if you don't know.
That's right.
That's where I always look at it. I can't know everything, even after, 30 plus years in the industry like you or more. And, we just keep learning and there's new things coming all the time. But it hopefully, in many cases, makes our jobs easier and better and we become more informed, which is really the key. You want to have the information to make intelligent decisions and judgment calls when those things pop up where you need to really evaluate things. And so this certainly looks like a tool that is going to be very beneficial to a lot of folks. And hopefully you get good participation on it. I mean, you can't beat the price from what I'm seeing.
Well, certainly initially we thought, oh, we need a paywall. We got to sell this. I said, no, let's just get it out there. And I won't promise that'll be the case forever because the maintenance of this might start to become costly. But I think it's important that we get accuracy on the hydraulic side. I'll give you a couple examples. I did an energy audit of a geothermal system in Pennsylvania where the pumping energy was more than all the heat pumps combined. The engineer felt that a single speed pump running 24/7 at full speed was the way to design a system. There were no two-way valves on any of the heat pumps, so every heat pump was getting flow all the time. And if you don't understand the impact of that, those loop temperatures got out of sight and the whole system failed. So these
Hmm.
details we don't have. Prior to this, I was not aware of any tool that would allow me to quickly get to the right numbers. And so that's why we said we got to get this out there.
Hmm.
I said I've been involved in forensics on way too many jobs. And quite often it's the pumping energy. One in particular, the Times Square ticket office on Manhattan suffered enormously from poor pumping design. And that was really the only problem on that system. But the loop temperatures got up to like 125 degrees. They had plenty of loop if they just cut back on the pumping.
Yeah. Well, that's a great point about overpumping, and so that's a kind of good segue even to some of the new IGSHPA training that we have out, like our new commercial system design class, our new residential system design class, and some of the others that we have. But those design classes particularly can help you forecast and take a look, and a training is parallel to help you take a look at that before you complete your design, and look how that thing's going to perform as an overall system, because you can pick the wrong component to make things imbalanced, which could end up causing you issues. In this case, like your example for Times Square, oversized pump, which is kind of unfortunate. So the training and knowledge information is out there today. There's lots of tools like John has that can help anyone interested in doing better jobs or getting into this work. And so certainly IGSHPA is glad to participate as an industry resource for everybody to help bring improvements as we move forward and learn more new things and do better jobs. And so we don't have to have as much forensics and bad jobs show up, because that does really unfortunately slow things down for everybody and can deter people from doing it. And if it's done right, like anything, it's a great thing, and we and everybody will appreciate that. So take advantage of the tools and the training that's available from IGSHPA and some of our members, such as John has here today with his new tool for pressure drops and pipe sizing. It's very informative and helpful. I don't see any more questions, John, popping up anywhere so far in the Q&A or the chat box. Let me take one more quick scan here, make sure. No, I don't, but I see lots of good comments. People are excited to see that and that new tool come out. And I think we'll wrap it up then. So we're right on time. Everybody gets maybe even a couple minutes back to their day today. Thank you for joining us. Thanks for your work, John, on this. I know that's a lot of code writing and a lot of learn curve on your part. So thank you for that work and sharing that information with us today. And hope everybody has a great day and a great weekend. If we can do anything, let us know. Thanks so much.
Okay, thank you, Greg.